So, good evening. Good evening. My name is Kovia Wimbers in Biomedical Laboratory Science in So I'm here to present from question 6 to 10, where I will start by the role of regulatory T cells in immune regulation. So the immune regulation, what we mean by immune regulation is the ability of the immune system to control and regulate its own response, where this regulates the immune response towards the body. So it does so by antigen-driven activation of the lymphocytes, negative regulatory influences that prevent or dampen the response. So the mechanism of antigen recognition by the T cells, these T cells are the ones that recognize the foreign antigen. But that foreign antigen, the T cells only recognize the foreign antigen that is attached onto the MHC molecule around the surface of the APCs. So each T cells, on its surface, it has it has an antigen or an epitope for it to recognize it. Again, the other roles, they help your immune response, they help in responding. In case of any foreign antigen that is entering within the cell, it just recognizes it. So at the same time, the drugs ensure that your immune response or the immune system does not attack its own self-antigens. For example, when we mean in autoimmune diseases. So the body is unable to attack its own cells or antigens. So these ones also help in the inflammation and organ transplantation. So here we mean also the central tolerance. The central tolerance, it means the eliminating or inactivating or removing the immune cells that are reactive to self-antigens. When the body starts to react towards its cells, it is called the central tolerance. We have three mechanisms: the negative selection of the T cells in the thymus, development of the regulatory T cells, deletion and energy of B cells. Energy, it means apoptosis, same as apoptosis. Thymus also, it is the positive selection where the T cells, they undergo the apoptosis as a programmed cell death. Also, the mechanism continues as we explore in the negative selection, where the CD8, they are transformed into the TDC. Also, this TDC, they proceed to the second lymphoid organism. So the T cells that don't bind self but do recognize the antigen that are found on the complex, and either CD4 or CD8, they migrate towards the lymphoid organs. We have also the B cell. The immature B cell, they are found in the bone marrow under the negative selection. So when they bind to self-peptides, properly functioning B cell receptor recognize non-self-antigen. It means that these B cells, they have receptors. These receptors, for example, when I explain these receptors, around these B cells, we have receptors. So these receptors are the ones where the antigen binds so that we can have a complex. We have also what we call the autoimmunity. Autoimmunity is when it's a condition or a disease in which the body immune system mistakenly, as in it doesn't want to attack its own cells, tissues, organs, leading to inflammation, damage, and dysfunction. So this autoimmunity, they also cause to autoimmune diseases. We will see it later. So we have different autoimmune diseases: the rheumatoid arthritis, Crohn's disease, Guillain-Barré syndrome, multiple sclerosis, systematic lupus, Hashimoto's, type 1 diabetes. So these autoimmune diseases, they are caused when the immune system starts to attack its own cells, tissues, the organs, and other various parts of the body. So we have also the immune checkpoints. The immune checkpoints, they are the regulatory molecules in the immune system that play a crucial role in maintaining the immune homeostasis. These immune checkpoints are the ones that prevent autoimmunity. But to the opposite of these immune checkpoints, we also have the immune checkpoint inhibitors. We will see it later. So how the cytokines regulate the immune responses is through production. How do they perform this? Through production, like the cell releases cytokines. These cytokines, they help during phagocytosis. We have also the reception. The cytokines travel through the bloodstream directly into the tissue until they bind to the matching receptor within the cell. We have also the response. As we know that when a foreign substance enters in the body, these cytokines, they respond in order to remove these foreign substances. Like we have also monoclonal antibodies. These monoclonal antibodies, they are very crucial. We have 3 applications of these monoclonal antibodies. One of them is through immunotherapy. They are used through immunotherapy just because within this immunotherapy we require the immunotoxins. These immunotoxins are the ones that we use in immunotherapy. So they work by triggering the immune system by helping it to attack the cancer. Mainly these immunotherapies, they are used in treatment of the cancer. So monoclonal antibodies, they are used in treatment of the cancer through immunotherapy process. They are a type of targeted cancer therapy, which means they are designed to interact with specific targets. As we see, these monoclonal antibodies, they have to come and bind. After binding, the antigen protein on the cell that can cause the immune system to respond. These monoclonal antibodies, they lock onto that antigen. So we have also the principle of the checkpoint. As I said, these checkpoints, they're the one that stimulate the immune system. But we have also the checkpoint inhibitory therapy in form of an immunotherapy that aims to enhance the immune system ability to recognize and attack the cancer cells. So these inhibitors are the ones that attack and recognize the cancer cells. So it works by triggering or by targeting the specific immune checkpoint proteins that normally function in regulating the immune responses, as we know. And this, they prevent the excessive tissue damage. So these checkpoints can exploit by cancer cells to evade detection and destruction of the immune system. So these checkpoints, they help within the regulation of the immune responses. So as we conclude, we use different these monoclonal antibodies, not only being performed within the immunotherapy, they are also applied within the imaging when they are carrying out those breast cancer therapies. Also, these monoclonal antibodies, they are used when I say immunotherapy. This immunotherapy, they involve, as I said earlier, they involved immunotoxins. For example, the most common immunotoxin we have, it is diphtheria. Diphtheria is one of the toxins that is used within the immunotherapy. So thank you for your attention. This is the end of my presentation. Thank you.